Why do UEFI and legacy BIOS create boot compatibility issues? Imagine turning on your computer and nothing happens. Instead of a smooth start, you get errors or a blank screen. That's often because of how the system begins its startup. The way a computer starts up depends on the firmware it uses. Two main types are UEFI, which stands for Unified Extensible Firmware Interface, and legacy BIOS, or Basic Input-Output System. These two systems have different ways of preparing your hardware and loading your operating system. Legacy BIOS is the older system. It works in 16-bit mode, which means it has limited ability to handle modern hardware. It uses a partitioning scheme called master boot record. This scheme can only support disks up to about 2.2 terabytes in size and allows only for primary partitions. The BIOS loads the bootloader from a fixed spot in the master boot record. This setup can cause problems with newer hardware or complex storage setups. UEFI is the newer system designed to fix these limits. It works in 32-bit or 64-bit mode, making it faster and more flexible. UEFI uses the GID partition table, which can support disks larger than 9.4 zettabytes and allows for many more partitions. It also reads file systems directly, making the boot process more adaptable. UEFI includes features like Secure Boot, which checks the bootloader's integrity before starting the operating system. This helps prevent malware from hijacking the startup process. Problems happen because each system expects certain standards. A UEFI system requires a GID partition table and a UEFI-compatible bootloader. A legacy BIOS system needs a master boot record and a BIOS-compatible bootloader. If these don't match, the system won't boot. For example, if you try to boot a UEFI-only disk on a legacy BIOS system, it won't recognize the disk's partitioning scheme. Conversely, a legacy BIOS might not be able to boot from a disk formatted with the GID partition table. Older operating systems often don't support UEFI. They need the legacy BIOS mode to boot properly. Modern operating systems, however, take advantage of UEFI features for faster startup and better security. This makes legacy BIOS less suitable for new systems. Switching between UEFI and legacy BIOS modes can require reformatting the disk with the correct partition scheme. For UEFI, you need a GID partition table. For legacy BIOS, you need a master boot record. Bootloaders like Grub can be configured for either mode but must match the firmware setting. Secure Boot, exclusive to UEFI, can block booting if the bootloader isn't signed or compatible. Some motherboards include a Compatibility Support Module, or CSM, which emulates BIOS behavior on UEFI hardware. This helps support older operating systems but can complicate the boot process. In the end, UEFI offers a more modern, secure, and flexible way to start up a computer. It's designed for large disks and advanced security features. Legacy BIOS remains useful mainly for older hardware and operating systems that don't support UEFI. The differences between these two systems and how they handle disk partitioning and bootloaders are the main reasons why compatibility issues can happen during startup.